We're going on now to characteristics of polynomials in topic 1.2. So let's look at first, they're having us look at 5 to the second power, and then later 6 to the third power. Well, as we see here, 5 to the second means 5 times 5, and 6 to the third means 6 times 6 times 6. So we have, when we start to look at polynomials, a way to give a shorthand of 5 times 5 and 6 times 6 times 6. We use what is called an exponent. So in our notation here, we're saying the 5 is the base and the 2 is the exponent. Now, what again does this mean? Well, this base is multiplied by itself the number of times as indicated by the exponent, and they have it shown here. And this is one of our definitions. Now, there is terminology involved in this. They're saying 4 to the 6th power, which means this. And similarly, in parentheses now, because this indicates your base, it's a negative 5. It means this. And again, this fraction to the 4th power indicates that. Now, in putting this in your calculator, normally you would put in, let's say, 1.2, then use this special key right here, which is called the caret key, and you get an answer. And they'll give you some examples to work on. Now, as I had mentioned before, there's a little trickiness every once in a while if you have something like this. Negative 2 to the 4th, and if you had in parentheses negative 2 to the 4th. Here, the base of this one is just what is immediate to the left of the exponent. The negative sign is not included in that exponential notation. So 2 to the 4th is 16. Then we apply the negative sign. But now, when you use parentheses, this indicates that a negative 2 is the base. So this becomes a positive 16. So keep that in mind, and they are giving you this caution here. Now, as we continue looking at the rules, suppose you run into something like this. 3 to the 4th power times 3 to the 2nd power. Notice your bases are the same. So what does that mean? Well, there are 4 3s and 2 3s. And if you add them all up, you get 3 to the 6th power. There's 6 of them. So a shortcut, instead of writing it all out like this, is when the bases are the same, you just add your exponents. And here is the rule. So this is what I would write in my notes. And then, of course, in your homework log, you're going to have some examples. Now, they do give you the examples and the answers. Now, a modification of this is when we say power of a power. And what we do here, and let me show you an example of this. So if we have a base that's raised to a power, and then in parentheses, this power is raised to a power, this means that you have 3 to the 3rd times 3 to the 3rd. And adding these up, you get a 6. But in this form, when you're raising it to a power, what would the shortcut be? Well, it would be multiplying your exponents to get 3 to the 6th. This was 3 to the 3rd raised to the 3rd. I'd have to add another one here. This would be 3 to the 9th. So there's what you see here. It's x to the 3rd raised to the 4th. So it's this 4 times, and you get a 12. So again, another rule for your notes. Now, another very important one is if you have a to the 0 power, any base to the 0 power is always going to be a 1. Now, a little later they're going to show you the proof of this too, but we could show it to you now. If I have a to the 3rd divided by a to the 3rd, now we haven't had this yet, but you may know it. The rule is you take an exponent. When it crosses the division bar, the sign of the exponent changes. So this 3rd here comes up to the top as a 3rd, and this would give us a to the 0 power. But we also know that a to the 3rd divided by a to the 3rd, anything divided by itself is a 1. So therefore, a to the 0 power is 1. Now it gets a little tricky if you have a negative sign in front here. If I put a negative sign in there, again, what's my base? Only the a. So this would then be a negative 1. So they get a little tricky. But remember, the base, any base to the 0 power is 1. But if the negative is not included in the base, then it would become a negative 1. Okay, now we're looking at a polynomial is an algebraic expression such as something like this, something like this, something like this, or just a plain 8. These are all polynomials. Now, they will tell us later the number of polynomials. If there's 3, This is going to be a trinomial. More than 3 is a polynomial. 1 term is a monomial, and this is a monomial. If it were just 2 terms, it would be a binomial. They'll be getting to this a little later here. So we have within a term, or within an expression, terms. And terms are separated by either a positive, and I don't see any negative signs. If this were negative, a positive or a negative sign separates terms. And within a term, such as this one, 5x to the 4th, we have a variable, which is a letter. We have an exponent. And the number part of a term is called the coefficient, or the constant term. This would be a constant term, or just the numerical part. So these are things they'll ask you to pick up in your practice and quiz me. What is the numerical coefficient? What is the exponent? What is the base? Things like that. Now remember, the base here is only the x, and they'll give you some practice work. Now another item of vocabulary that they'll be asking you to work with is, what is the degree of something, what is the leading coefficient, and what is the constant term. So there is our polynomial, and the degree of something is defined as the, let's say something like this, 2x squared y to the 3rd. I don't know where my z to the 4th. So this is all just one term. Now the degree of this term would be the sum of the exponents on the variable. So here it's 2, 5, 3 is 5, 4 is 9. So the degree of this would be 9. Now the numerical coefficient would be the 2, and that would be what they have for this. So let's look at this one here. Now if there's only the one letter, like x to the 7th, then the degree of that is 7. So here we have x to the 2nd, 7th, to the 3rd, to the 2nd, to the 1st. Now if there's no number by it, it's to the 1st. So the degree of this polynomial is 7, because that's the greatest number of exponents, value of exponents on the variables. Now the leading coefficient would be the coefficient of the largest degree, which is 6. And then the constant term is 10. Now the degree of this one is 4. Now when you have like a negative x to the 4th, there's a 1 in front of that negative. Well, in front of the variable after the negative. So that's where they get the 1 from. We just don't write it usually. And then the constant is 1/2. So here the degree is 3. Again, we don't write the 1, but that would be our leading coefficient. And there is no constant term. They're saying there is none, so it's like 0. Again, 0 doesn't have any value. And then 12, there is no degree. The degree is 0. Leading is 12, and the constant is 12. Okay. Now they're taking you into the skill of adding and subtracting polynomials. And the key to this is which are the like terms, and those are the ones you can add. And if they're not like terms, you cannot add or subtract them. So what are they talking about? Well, over here we have y to the fourth. Y to the fourth. So these are like terms. In a sense, we could factor out the y to the fourth from each of these, and we just add our numerical coefficients, and that gives me the answer. And again, these are like terms. The variable and the exponents are the same. So we just add the numerical coefficients, which gives us this. Now again, if I were a student, I would look for a way to do these with some success. And they're giving you some examples, and they do get a little complicated. Now, my suggestion, and again, they're doing this horizontally. Now, you can do it the way they are describing it here, kind of grouping the like terms horizontally. But I like this idea of lining them up into like term vertical columns. So I just take the 8, put it there, this there, this there. And then from here, I'm putting these under the like term columns. So now when I add this up, and then here I'm careful of my signs. Now don't put a 1 there, although there is a 1 there. Then it's much easier, I think, doing it this way. And if it's real easy, you could do it horizontally. But there's a tendency to, mess up somewhere on one of the signs or something. Now, this is addition. So this is pretty straightforward. You're just adding unlike signs in some cases. Now, if you have a subtraction, that's a little more challenging. And notice, this is now subtract whatever's there. So the rule for subtraction is to change the signs internally of what's inside the parenthesis. So if there's a negative outside, then the 4 becomes a negative, the 3 becomes a negative, and that ends up being a -7. So in looking at subtraction here, now we want to suggest a way to get it right. So you could do it horizontally, but I'm going to suggest you do it vertically. So I've just copied this down carefully. Now I have a negative sign in front of a parenthesis. So what I'm going to do is take away the parenthesis and change each of these signs. So this will become a negative 7x squared. This will become a positive 6x. And this will become a negative 2. And again, it doesn't hurt to check your work. A negative 7x, a positive 6x, a negative 2. Now you can't go wrong. So this is a negative 5x squared. This becomes a negative 5x. And this becomes a positive 6. And there's the proof of your work. And this is what you'll be writing on your blue sheets as you take your test. Again, you could do it horizontally, but I like the idea of lining it up vertically and very carefully checking your answers. So now notice they're getting this a little more complicated because we're using the distributive property now to find each product. We're going to multiply this monomial by this trinomial. So in a sense, this is multiplied by each term within the parenthesis. Usually you do this step mentally and you get this. Now here's another case where it's a binomial multiplied by a trinomial. So again, this 3k by each of these and the negative 2 by each of these, and they're showing it to you horizontally. Again, I would suggest we set this up vertically. Now back in Math 1103 we did this and we spoke of the FOIL, but again the way this is working here in the traditional sense, they're taking the first term of the first binomial and multiplying it by these two, which is right there. Then the second term of the first binomial and multiplying it by these two, and you get this. Okay? Now, this gives rise to what they'll be introducing here very shortly, what we call the FOIL, which is a method of multiplying binomials. The F stands for these first. The O stands for the outers. The I stands for the inners. And the L stands for the last. And notice that usually your inners and outers are like terms that you combine to get a middle term here. So you have multiplied two binomials through a special pattern that you'll want to master to get a trinomial, because later we're going to take this trinomial here and we want to factor it. So multiplying is sort of the easier way to go. Factoring it is the more challenging, but we'll work on it little by little. And there they're telling you the FOIL. Now, a modification of this is when you see, and let's do one of the foils up here. Now, in the beginning, you can actually, make a line here and say these are your first. So that's going to be a 3x squared. Now you have your outers, which is a 15x, and your inners, which is a 2x, and that you can mentally add those together and get 17x. And then you have your last, which is a plus 10. And we did that well. We copied it correctly. Now a modification of this is this one. And you could theoretically write it out again, and that's what they're doing here, and you FOIL it. But there is a special way of doing this, and that is to square the first term, and I'll write it underneath here. That gives you an x squared. Multiply these two together, 3x, but now double it. That gives you a 6x. And then square this last term, and that gives you the 9 here. Now notice when you multiply your inners and outers, they're the same. That's why just multiplying these together and doubling it, it's just a shortcut of doing it. But you can always just FOIL it the regular way. Now this one, interestingly, has a special name. This, which is a result of squaring a binomial, is called a perfect square trinomial. And you might say, why is that significant? Because later, if you can recognize this will factor into a binomial square. So, leading up to things we're going to be doing a little later. Okay, now they're giving us a little application here. And let's look this over. So here they're giving us this application. In business, the revenue from sales of an item is given by the formula revenue is equal to the price per item times the number of items sold. The cost to manufacture and sell these items are given by the cost is equal to the fixed cost, and they define that down here, and the variable cost. And then we have profit is equal to revenue minus the cost. So here they give us a particular example that you will read through. They're describing everything in detail. And if X thousands calculators are sold at $12 each, then the revenue, that would be the price you gain for each item, times the number of items sold, would be this. But since there was some fixed cost and variable cost, we have to figure out what our fixed costs are, our variable cost, and then using this formula, and you'll have to write it out to get the practice of it, you eventually end up with your profits. Okay, well, you'll be doing some practice. This one was just a little bit shorter than the other. And there are plenty of exercises. And good luck.